Hey guys, and welcome to the Linux introduction tutorial video. I'm going to try and keep it short and sweet and to the point. The idea behind this video is to just give a basic exposure to what Linux is. The video is aimed for the first time you load Linux, the first time you boot into it, and I'm just going to run you through how to get around, how to do basic file configuration, making files, permissions, sort of that kind of stuff. Just give you a feel for what the Linux environment is about. I'm pretty much making this video from the perspective of what I wish I had found straight off the bat when I first jumped into Linux. I found it a bit daunting. You know, it's an entirely new operating system, it's an entirely new world, and I'm just making this video to make that process a little bit easier. I'm using the Kali Linux distribution here, as further videos will be touching on different exploits, cracks, that kind of stuff, and Kali is a great distribution for that. Now, first, I would really recommend that you download Kali, pause this video, run a virtual machine, and follow along through this. Just make this half the screen, open your VM in the other half, and just follow through what I do. It's one thing to observe something happening, it's another to then recreate it yourself. It'll fit into your memory a lot better, and then when you get stuck, you'll be able to call on it a lot easier. Alright, so the first time you open up Kali, you'll be greeted with obviously the login screen. The default for root password is Tor. T-O-O-R, or root backwards. And then you'll log in. Now, as you can see here, as it adjusts to the resolution, this is Kali Linux desktop background. Something just to point out, the applications menu up here, top left, is similar to the start menu in Windows. Browse and run installed applications. You've got your accessories, electronics, graphics, blah 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 blah. One of the options here to note is the Kali Linux tab, and this has all your penetration tools. You've got the hardware hacking, stress testing, wireless attacks, all a bunch of little good tools here, and we'll be going through a few of them in later videos. The top 10 security tools is just the most common ones: Wireshark, Metasploit, Aircrack, Hijack. I'm sure some of those names look familiar to you. We'll flesh out what they do and how they do later. First thing you want to do when you run your Kali or Linux distribution is update the repositories in the operating system. The repositories are when you go to install a program, where it goes to find to install that program. Top left here, open up a terminal. To update the repositories, we run the upget update command and the apt-get upgrade command. Now I'm pressing Control C here just to kill the command as it's running, as there's no point. I've just run the command, there's no point running it again. The Control C is the kill signal. It will interrupt whatever you're doing and just kill what's running, kill the process. It's the equivalent of using Task Manager to an extent in Windows. A beautiful little nifty trick in Linux is using the double ampersand sign. This runs two commands at once, so I can actually do enter like that, and it'll actually run through both the commands. If you've reading an online tutorial or you've just come across it before, you might know that there's an apt-get dist upgrade command. Now this command is very similar to just the plain upgrade command. However, the dist command uses what's called a smart updating filter. Now in upgrade, it just finds anything that's new, throws it in there. Dist will, using the smart filter, go through the repository and go, oh, I don't think this one's needed anymore, I'm just going to delete it. Pretty robust. However, just like with technology, sometimes things go wrong, so just to prevent any headaches or any problems, stick to this one. You'll be sweet. To clear the terminal, Linux, just type clear, hit enter, brings you back to a fresh new screen. Now I'm going to be a little biased here and recommend you download a program called Terminator. Now Terminator is just another terminal, however it's got a bit more user functionality around it that I really do find useful in some of the things I do. To install program in Linux, apt-get install, program name. This will then go to the repositories, and the repositories will point where to download it. All happens behind the scenes. All you got to do is apt-get install. Now I've, as you can see here, already run it. It doesn't need to be upgraded, doesn't need to be reinstalled, doesn't need to be removed. Once you run that command, just exit the terminal, go through applications, accessories, and you'll see here Terminator. What I like to do is just drag it up to start bar there, click on Terminator, and we're in, we're ready to go. One of the most useful aspects to the Terminator is the ability to open up multiple tabs, sort of like in Chrome, for different terminals. You can press Control-Shift-E to split the screen horizontally, and you can press Control-Shift-O to split the screen horizontally. Very useful if you're going through a program, you need to compare source code with what you're writing, or just trying to work out how things are running. To close the terminal, we just enter in the exit command, and we're good to go. Alright, so now we're set up, we've got the latest repositories, we've got our terminal, emulation, program, we're all ready to go. Now, folder structures in Linux work similar to Windows, but they all kind of work off the tree sort of aspect. So I'll just bring in a tree over here, rotate it. In Linux it's upside down, so as we work through different folders lead to more folders, lead to more folders, lead to more folders. Now if we work upwards, we can see all of it comes from the root. Everything begins at the root. This is the same in Linux. If the top of the file structure is the root. The root is symbolized by this backslash. That is the root. If I go to the root, that's where I'll start. Now to change your directories in Linux, you use the cd command and then the directory you want to go to. If I want to go to the root, cd to the slash, now I'm in the root. You can see at any time where you are with this command here, or you can type pwd and it'll tell you where you are. So if I change directory into a folder called var here, it'll tell me that I'm at root/var. Same with the pwd command. Also in Linux you have your home directory. Your home directory is represented by this tilde sign. The tilde is the funny little squiggly line to the left of the exclamation mark. This is the equivalent of the My Documents in Windows. Also, other thing important to note, single dot is to the current directory, so what this is saying right now is change directory to the current directory, so I'm not going to go anywhere. 2 dots means go to the directory above where we just are. So if we go back to cd/var, this is where we are. If we cd to the dash, now we're at the root. We've changed directory up 1. Let's go back to our My Documents and clear the screen. Now, to make a directory in Windows, we use the mkdir command. Make directory, pretty simple to remember, and then the name of the folder you want to create. So I'll do make the example. I can now change directory into this example, and it'll tell me I'm from the My Documents /example. Exit back out, cd, back up we go. To list the files in a folder, you use the ls command. ls stands for list segments. If I run it here, we're not going to see anything. If I go back to my Documents folder, we can see that I have here a tarball file, which is the same as the .zip in Windows. I've got my desktop folder, got the example they just made, and I've also got a pcap here from Wireshark. By default, grey is a text file, blue is a directory, red is a zipped file, so to speak. The beautiful aspect of Linux is that when you run a command, you don't have to run it at just its basic form. You can use little parameters to feed into the command to make it do more detailed other operations, that kind of stuff. So by default, when I've just run the ls command here, it's listed all the files in the directory horizontally. It hasn't done hidden files, it hasn't done files I can't access, it's just listed what it can see straight there. If I want to list with some more details, I use the -l command. This little dash here is actually called a tac, so if I go ls tac l, that's what I'm referring to. If we now run this, we can see our directory contents listed vertically, when they were created, date they were created, the size of the file, who actually owns the file, and then these are permissions relating to that file. We'll go through this in a little bit later. With the ls command, I don't know about you, but I can't read how many bytes that is. It doesn't look too friendly to me. So I'll run the -h command as well. This H stands for human readable, and now I can see 1.2 megabytes, 4 kilobytes, 2.8 megabytes, rah rah rah. Beauty, just to make life a little easier, in Linux you can run the commands when they're all of tac together. You don't have to enter in a new tac each time, so it's just going to do the same thing. These run exactly the same commands. Another useful little aspect to list segment is the -a command. This will list everything, hidden folders, hidden files, hidden whatever. So as we can see here, I've got .configs, .caches, .bars. Anything beginning with this dot is a system hull. It's by default hidden. -a parameter brings it all up. Running them all together, these are every piece of information in this directory at the my document, so to speak, of the root user. Going back to our example file, example folder, we have a file in here. If we ls dashes, this is the permissions relating to this file. To change these permissions, we use what's called the chmod or change mode command. The way this is broken up is it's broken into 3 different classifications of users. The first 3 is the owner of the file, the second 3 are groups, the third is other. So everyone else that doesn't fall into those first 2 categories. So just to write that out, you've got user, groups, other. The R stands for read, so read permissions, the W, write permissions, and the X is executable. Pretty straightforward, etc. If there's a tac, means no permission, nothing granted. If I want to add executable rights to the others section here, alright, chmod, I want to do the others plus, because I'm adding the permission X to file. Run that command and we can see now that the others group can now execute the file. So the command, the syntax for that was chmod permissions to be changed file name. If I want to take away -x file, there we go, it's now been taken off. You will also see in some areas where people use numbers. Now suddenly I've given all permissions of everything to this file. The most common one you'll see is the 755 command. what this does is it gives access, all access for the owner, and read and executable rights to everyone else. How these numbers are being calculated is each number represents each section. So the first number represents the first three, or the owner. Second number, groups. Third number, others. So if I enter 700 here, I've now given myself all permissions and 0 to everything else. The highest number here is 7, and that's all the commands. The way this is all worked out is R stands for value of 4, W stands for value of 2, and execute stands for value of 1. Add them all together and you get 7. That's the way that works. To demonstrate this really easily, I've found a quick little calculator online just to give you a visual representation of what actually is being done here. So I'll just bring this in. As you can see, 0000, owner group other, if I, 426, right, 1, so this came up with 621 here. If I now give this, run this command, we can now see owner has read and write, the group has only write, and others have executable. This first little tack here refers to whether it's a file or a directory. So if I now make my directory, I list again. Directories have the D, files have the tack. It's good practice in Linux to not be logged in as the root user. This is because if you do something you weren't meant to, you accidentally break something, you run a virus, you just accidentally set fire to the house, if you're on a limited user, it serves as damage control. You can't obviously delete important files from a limited user. However, when you're logged on as a limited user, sometimes you need to run commands as the administrator, as the root user. In Windows, it's the equivalent of right-clicking and pressing Run as Administrator. In Linux, we use the SU command. This stands for Substitute User. Currently, because I'm logged in as root, I don't need to use this. Everything will be run as root. But if I was logged in as somebody else, I would do su root, and I would be able to view files as that person would from that screen. So to give a quick example, we'll just add a user in here, and then we'll view as Alice would. So this is what Alice would see in the files if she was logged on. To quit out of that, just exit, and we're good to go. All these commands I'll be showing you have obviously they're very powerful. I'm not going to run through every little command that can be done with them. You'll come across them in your time as you need to do different things with files. To view all the commands though that a program can do, you need to refer to the manual, or in Linux it's man. Now the syntax for this is man and then the command. So for example, if I do man change chmod or change mode, it'll bring up here all the different options for the change mode. It's got a description here, what it does, setup, and down here we've got our options. So as we can see here, the -v stands for boost, and it's an output, a diagnostic for every file processed. Let's have a look what this looks like. So we've still got our file command here, we just read write like that. If we give stand permission to this file with the verbose output, it's giving us the mode of file changed from what it was previously to what it is now. And we can confirm that with the list segment command. There we go. This, you can essentially look at the V as verbal diarrhea. It will tell you every single step it's doing, what it's doing along the way. A lot of commands in Linux will have the -v command for extra output. To create a file with any name, with any extension, without actually modifying the file off the bat, we use the touch command. And the syntax is touch file name. So currently we've got just the directory and the file listed here. If I touch my file dot anything, then run the command, we can see the file's now been added here. It's empty, there's nothing in it, but the touch command just adds a file. This is very useful later on when you use scripts and you need to actually generate files, so just keep that in the back of the mind. Now that we've made a file, how do we delete it? Remove, or in Linux, rm. Similar to the touch command, the file for this is rm, and then the file name of what you want to delete. So if I rm the myfile.anything, it's now gone. If I make a really long file name that I don't want to type every time I have to access it, right here, a little very useful command you can do here is use the tab. Now, beginning this starts with an A. If I press the letter A and now tab, it's going to fill in the rest of the file name for me because nothing else starts with A. If I have another command that starts with a really long, looks similar to this. Now they both start up to here with the same command. If I then press the tab on the A again, it's going to fill in all the same characters up to where it differentiates. Now if I want this one, I'll type the letter D, tab again, it'll fill it again, fill in the rest. I could do F, there's the rest of it. Alright, with another part to note with the remove command is that if I try to remove a directory, I'm going to get thrown this error here. Cannot remove x2 as a directory. To get around this, you use the -r command. This stands for recursive. What it will do is delete the directory, anything in the directory, all of the directory, and nothing but the directory. Now, just to demonstrate here, directory is gone. Now, this can be a very dangerous tool, so run it wisely, as if I remove -r from the root, this command right here is just gonna wipe the system. It's essentially the equivalent of deleting system32 in Windows. It'll just keep deleting itself and still everything crashes and burns and cries. So we've gone through how to make a file, how to remove a file, how to change the permissions on the file. To move a file, we use the mv command, stands for move. The syntax is move current and where you want it to go. If I have my directory here of hello and I want to put the file in hello, I would move file into the hello directory. As we can see here, it's not there, and here it is. I used this // command is to say put the file in the current directory /hello. As if I'm in the hello directory, I press pwd, you can see /root/example/hello. Going back up, this is /root/example. So this dot takes the current path, then I'm just adding the /hello to the end here so it knows where to put the file. To take a command to move a file, up a directory, as we remember before, and I've just showed here, the double dots means take it to the directory above. So if I move file to the directory above where I currently am, it's not there, and here it is again. You can also use the move command to rename a file, similar naming convention. All it's done is renamed it, moved it, that kind of thing. You can also use the cp command to copy a file, and the way to copy the file, similar command to the move. We're done like that. You can also copy into directory similar as the move. Alrighty, now we've known how to create a file, move a file, copy a file, basically just useful stuff to use with files. Echo is a command that anything I type after here, it's just going to print back to the terminal, or can also be known as standard output. It means the same thing. If I echo hello world, terminal prints back to me hello world. In Windows, in Linux, the pipe command is the technical way of saying it, is the redirection of the output direction. So in here, echo is going to print it to the terminal. If I put this pipe command in here, instead of printing it to the terminal, it's going to give all this information to whatever I put after here. If I want to run it through, I could use pattern matching here to then go through and take out what section of the words I want. There's just a very large multitude of things to do here. If I want to write to a file, I can use the single greater than sign here, and now the myfile.txt will have the words hello world in it. To print out a file to the terminal, we use the cat command, stands for concatenate. All it pretty much is everything in the file, read it out to me to the screen. There we go, we can see right here. An important note here is that if I now do repeat what I just did with the echo command, day into myfile.txt, this is going to overwrite what was already in the myfile.txt. We've lost our hello world, it's now day. If we want to add to the bottom of the file, what we do is we use this double greater than sign here. What this means is, it means append. It means at the end of the file, add what I just gave you into it. There. Another example. There you go. So cat is used to print to the screen. However, if I have a really big text file here, for example, in this folder I've got Martin Luther King's speech in text form. If I cat this file, it was pretty big. I have to now scroll up to get back to the beginning of the file. Doesn't even show me the beginning of the file because the file is just too big to bring to the screen. If we bring this up here, we can see that it's 9 kilobytes of text. That's a fair bit. To go through it systematically, we use the less command. Now what this will do is it'll give us the ability to, using the up and down arrows, go through line by line as we want. You can also use the page up and down, scroll through the file. To quit less, you press the letter Q and you get out of it. Now, say I want to print the first 3 lines of a file. This can be done using the head command in Linux. The basic syntax for it is that where N stands for how many lines you actually want. So for example, if I had just one of the dream, it's going to give me the first line. I'm happy to join with you today and what will go down in history is the greatest demonstration of freedom in history. So we want 2 lines, 3 lines, so on so forth. To get the end of the file, you use tail. Same convention as the head command. Let's say I want the last line, last 2 lines, last 3 lines. Pretty simple all the way through. To get more information about a file, we can find out how many words, how many lines, how many characters were in file using the WC command. This command stands for word count and is similar to Microsoft Word's word count. By default, it's just WC and then the file name. So for this example, dream.txt. Now what this tells us is that there's 87 lines, 1,666 words, 9,201 characters. Because this can be a little difficult to remember, we can do the tac command for whatever we want. So let's say I want the lines, I'll do -L. There's 87 lines. If I want the words, 1,066, and if I want the characters, 9,201. Lines, words, characters. Pretty simple, pretty easy, very useful. An example of the pipe now is if I cat file into word count, count the lines, it'll just tell me straight off the bat how many lines are. So to go back to the pipe redistribution of standard input, this is by default going to print it to the terminal. What I've done is, hey, take everything you're going to do to the terminal, chuck it in this pipe here, give it to the WC command and let it run what it wants to do with it, and then as there's no more pipes here, just print it back to the screen. Could do the same for words. The next command we're going to use is the find command. The find command is useful for doing exactly that, finding a file or a program that you want to know where it is. There's different versions of the find command. One's called locate, one's called where is. We're only going to start on the find command today. The syntax for it is find where I want it to search. What am I looking for? So if I want to find from the current directory, a dot, the dream file, it tells me here it is. If I go out here, search the current directory of the home directory of the root user for dream.txt, we go like that. If we don't know the entire name of the file, we can use what's called regular expressions, or just to keep it real short, if I chuck this star here, find something that starts with dr and just throw in the rest of the characters here. I don't care what the rest of the characters are as long as it starts with dr, and it'll bring it back to me. Otherwise, I have to get the entire file, name convention correctly, otherwise it's not going to come up in my find command, as we can see here. So find from the current directory, name of the file starts with Dream, don't really care about the extension. So I went, okay, well in the current directory we've got the intro folder, so it searches all of these folders as well. Searched a desktop, searched example, and searched intro. When it was intro, found a file that began with Dream, text. Simple, straightforward, useful. Now the grep command stands for Global Regular Expression Parser. What this essentially does is it's a pattern matcher. If I give it a pattern, it'll search a file that I've also specified for that pattern. So if I grep for the word dream, let's go into the file. If I now grep for the word dream in dream.txt, it now prints to me every line that it found the word dream. To make this a bit more obvious, we can use the -tac color command, and it will actually highlight for us every time this has come up. If I only want the word to respond, I don't care about the rest of the line, I can do the -o command. Just brings back dream. If we want to know where this was, we can use the -n command, and it will actually tell us on what line of the file dream occurred. So 31st, 37th, 45, etc, etc. grep is very useful in searching files for keywords that you want. Another example of the pipe command is instead of printing everything to the screen, I'm going to push it all into grep, search for the word dream, then I'm going to add it to my file. Sorry, I want to match only the word dream. I want the numbers of the file as well. I don't need to specify the file here because it's taking the output from the pipe, which is the cat command, and I'm going to put this all into, append it to a file called result.txt. Even if this file doesn't exist right now, when I run this command, it will generate that file for me. Now have a look. Now we can see here all the lines of occurrences of the word dream in the speech as a result of this output. Sed, or Streamline Editor, is sort of like grep. It does pattern matching, but it also has the added ability to replace what pattern you found. The basic syntax for the sed command is sed s dash what I want to find, what I want it to be changed to, slash. So if I've got the word day here, so I'm echoing day to the screen, I pipe this through to sed, let's search for the word day, change it to night, now it says night. This last slash has the ability for how many times you want the sed command to replace what it's found. In this instance, by default, if you leave nothing there, it's only going to do it once. So it found the first day here, changed it to night, but it left the second day. Just let it go through. If I add the G here, that's global. That means every time you find it, do it. Now we've got night, night. These are really off the bat all you need to know about the sed command. Now that we've got our file, let's say we want to add some text to it. The text editor for Linux
there are two extremely popular ones. One is called Nano, one is called Vim. There's quite a rivalry between the two. To summarize the differences between them both, Nano is much more user friendly, straightforward, pretty, just jump straight in, you get what you're doing. Vim is more powerful, but a lot more complex. There's a much steeper learning curve with Vim. So we're just going to stick with Nano here. To jump straight in, we run the Nano command, and then the file we want to edit. We're now in the file, entered in our text. Down here we can see this power sign stands for control, so if I press Control X, I'm going to exit. Can also read, where is, previous page, cut the text, uncut the text. You got all more commands here. So I press Control X. Do I want to save it? Y for yes, N for no. Enter in the Y command. It'll take me to the name of the file I want to write it to. Let's say I want to change it to Hello World Everybody. Just type everybody, hit enter here. It's going to tell me, am I sure I want to change a different name? Y again. Now if we run the ls command, we've got our file here. To change it within the same file, Control X, then just press Y. Want to keep the same name, so I'll press enter. Now if I print out that file contents to the screen, there it is. One of the most useful things with Linux is the ability to automate processes, and this is one of the things that makes Linux so powerful. The Born Again shell, also called bash, allows you to write a script and execute a script over and over, so you don't have to keep repeating stuff. I can just run a script to do the same thing. Classic example would be is, say I want to back up the directory of my documents. I would write a script that backs it up to an external location. Then once a week all I have to do is run that script. I don't have to write the command every time. I don't have to write it out, waste time. I can just run that script. All scripts in Linux end with this sh, stands for shell. It's not going to work without that sh. So let's make our first script. Banana, we're going to call it myscript.sh. Jump right in. Now every time you make a bash script, you got to throw this shebang bin bash at the top. What this means is, what it tells the computer to do is, if I write something here that you don't know how to do, go ask this location first how to do it, then if that location doesn't know how to do it, come complain to me. So pretty much if I tell it to echo, it's going to go to bash and be like, do you know how to echo? Bash will be like, yeah, do this. So instead of the program crashing, it runs through. All the script is going to do is run the echo command to the hello world. We'll save that. Now if I try to run this script, I'm going to get a permission denied error. This is because if we look at the permissions here, we've got my script. I don't have executable rights to this file. So for myself, I'll add X to my script, and now I can run the myscript command and it tells me what I'm doing. If I jump back into the script here, Control K, delete the line, I can create variables and then use those variables in bash. To make a variable, the beauty of a scripting language is just write it. Call it my variable, my var, and I'm going to say hello world. To refer to variables in bash, begin with the $sign every time. It is also case sensitive. Now what this command is going to do is it's going to create the variable myvar with the hello world string, then print it to the screen. Let's demonstrate this. There you go. If I want to put that into a file, I can then change this to make the file do whatever I want. It's kind of like the terminal. Something also useful here is loop commands. So if I what this is going to do for the variable I in the sequence of 1 to 10, so just go through 1 to 10 for each time, print out the variable. In fact, we'll change that to say my number is, and we'll save that and then run the command. Sorry, instead of the single apostrophe here, it's the not shifted version of the tilde. Save it. My script, there we go. So it runs through the loop 10 times. One more time, there we go. Something else we can do here, very useful, is we can iterate through all the tell it to iterate through a bunch of variables. So what this is going to do is it's going to run the ls command, and for every I or line, actually I should, to make this more understandable, I'm going to change for every line in the ls command, print the word found and then what it found to the screen. We now save this, run this, hello world, our numbers, and then all of the ls command is found. Verify this running ls, we got the 4 files, there they are. Something also very powerful about bash is the ability to use functions. Now functions or methods are sort of like a script in a script. If I call my function a and I tell that function to print hello world, every time I run that a function in this script, it's going to print hello world. So just example here. What it's going to do, so I've defined the function a, always use the curly brackets. The curly brackets means that for the function of a, everything will be run in between the curly brackets, and then I've just called the a function here. I now run the script, it says hello world. I can do this lots of times. Hello world, hello world. To combine what we just learnt before, for I in sequence 1, 2, 5, do a, done. There you go. 1, 2, 3, 4, 5. Now the way you write these functions, doesn't matter what way it's wrote, it's the way you call it. So if I have a function here called quit and it just exits, and a function here called e, and I'm gonna throw something fancy in here, $1. And what this $1 means is the first parameter, that it's passed with the E, print that to the screen. So if I call the E command with the parameter hello, it's now going to print the word hello to the screen. I'm then going to run the quit command, and for point of proof, if that quit function isn't run and the program is an exit, we're going to see this word hey. If it is exited, we're not going to see that. Run it. It's always useful to spell words correctly. I should have noticed that before by the way the word was grey, which meant that it hadn't been recognized in bash. Now that it's green, it realizes it's got to do with the function. Come back out. There we go. Hello world. Then it's quit. We can't see that echo of hey. Something also useful that you can do is you can take user input into the command. So for example, when we use the read command, and we'll call it. Can do multiple variables with this. First name and last name. We'll go the last name first. There's no reason to stick in that order. John Doe. Hi, Doe John. I cannot stress enough how useful and simplifying life makes being able to use bash to write your scripts. Please go to Google, please type bash introduction tutorial, please go through it. It will just benefit you immensely. An important difference just to note here is that bash is a scripting language, it's not a programming language. Although a lot are the same, you've got functions, you've got for loops, you've got while loops, you've got if statements, whatever. The fundamental difference between a programming language and a scripting language is the hardware dependability. If I write a program in Windows, I can't run that program in Linux. If I write a script in Windows, I can run that script in Linux, and vice versa. If I make a file program in Linux, I then can't run that on Windows. Okay, alright, that basically sums up everything I was going to go through with this video today. I hope this has given you just a basic oversight into what Linux is, how you use it, basic commands, how to move around, and the exposure to shells. If you've got any questions or anything, just let me know. I'm happy to go through it. I'm happy to expand on the commands I've gone through, but I would really recommend practicing your own ability to learn commands on your own, either using Google or using the manual to work out all the different options you have there. You have an unlimited range of tools and so much that you can do. Alright, enjoy and have fun.